myself Dr. Priti Jagwani from Department of Computer Science, Aryavat College, University of Delhi. So in my previous lectures under this series of artificial intelligence, we looked into various properties of environment, we understood the topic of peace, and we also seen the concept of rationality. Now this course is about the study of agents, and today we are going to look into various types of agents. So when we say types of agents, there are basically 4 types of agents. One is simple reflex agents, second is model based agents, third is goal based agents, and fourth one is the utility based agents. So our today's topic is that we are going to look into these agents into kind of detail. So when we talk about the first one, which is the simple reflex agent, we can say that is the simplest kind of agent, and this simple reflex agent depends or selects the action on the basis of current percept only. More importantly, it is going to ignore rest of the percept history. So percept history it is not concerned with, it will only look into the current we can say percept. So for example, vacuum cleaning agent. So if we look into the vacuum cleaner world with just the 2 locations that we have already seen this example. So there are 2 locations A and B, and there is a vacuum cleaner and some amount of dirt is there in both these, and it is taking the percept in the form of A comma clean. So for example, A is clean, then the previous percept or the history of the percept here, that could be that A was dirty, but now it has been the dirt has been sucked and the current percept is A clean. So if the current percept says A clean, then the next action will depend entirely on this A clean, and that action is moved to the right. Now so for example, it will suck the dirt over there and then it will look on to the kind of next action to be performed, ignoring the history, whatever percept history has been taken up. So for example, A clean, then the action will be moved to the right. If A dirty, then action will be suck. And for example, at the 5th number, if you can see, there is a sequence of percept which says A clean comma A clean. So in both the sense it is going to move to the right, but if your percept sequence is something like this, that A clean and now A dirty. So previously A was clean, but now A is dirty. So that means it is going to suck the dirt. It is not going to look into that previously the A corner was clean. So history of the percept or the percept sequence is completely, we can say, ignored when we talk about simple reflex agents, and that simple reflex agent is exactly going to work according to whatever current percept has been kind of taken up. Now agent program we talked about in our previous lecture. If we want to write an agent program, or we can say if we want to write a function for this reflex vacuum agent which is going to take location and the status A comma clean or something of that sort, or B comma dirty or something of that sort, it is going to returns an action. So input is the percept which is in the form of location and status, and it is going to return an action, and on the basis of this dimension we have kind of tabulated these simple agent functions. So if status is dirty, then the action will be suck, else if the location is A, then it is going to move to the right, else if the location is B, then it is going to move to the left. So in this way we can define the agent program for simple reflex agents. Now what is we can say is important thing here, that in this agent program we have written some rules in the form of if then else conditions. Now please remember this. Also simple reflex behaviors occur can occur in a more complex environment. So for example, a driver of an automated taxi or automated taxi which we were talking about, if the car in front brakes, then its brake lights comes up or brake lights is light up, and one should notice and then initiates the brake of itself also. So, this is actually this kind of behavior we can say can be coined with the help of all those if then else condition rules if we talk about. So, such a connection, a condition action rule can be written as if the car in front is braking, then we also need to initiate the brake. If we need to look into this simple reflex agent with the help of a systematic block diagram, then here is the diagram in which there are two portions to this particular figure. On the right hand side we have environment and on the left hand side we have agent. Now, sensors are there and so are actuators on the top and the bottom respectively. So, sensor is something through which environment can be perceived. You can kind of notice the direction of the arrow, and actuators because these are there in order to act upon to the environment. So, actuators so the direction of the arrow is from agent to the environment, while in sensor it was from environment to the agent. Now, simple reflex agent is going to look into what the world is like now. That means what is the current percept, what was the world before this, what was the current percept history. Your agent is not at all going to be kind of not at all going to consider this. It is only behaving on the basis of current percept, and on the basis of current percept it is going to decide that what actions should I should do now. And in order to decide that what actions the agent is going to do now, there is a repository of condition action rules. So, by taking the help from condition action rules and by looking into whatever the current percept is. So, okay, if this is the current percept, then we need to do this because this is written in the condition action rule. So, this is what the whole idea of a simple reflex agent is, that it is going to decide everything on the basis of current percept. It will look for the current percept, and then that current percept is going to be searched or looked up in the condition action rule table by following a table lookup activity, and whatever action is going to be associated with that current percept, that will be kind of performed. If the current percept is absent or not available in your condition action rules, then it is going to kind of fetch an error or it is going to do nothing, because it is totally dependent upon that current percept and it's looking up into the table also. So, if we say if we need to write a general function which we have already seen for our vacuum cleaner agent, if we need to look for that function in terms of a general simple reflex agent, so it is going to take the percept and it is going to return an action. And what is the persistent item here is, the persistent item or what it is having is the rules, which is the set of condition action rules, that repository I was talking about. Then there is an state which is going to be determined with the help of current percept. That means that percept is going to be, which is in the form of an input, that percept is going to be interpreted and kind of we can say gauged as a state, and a rule matcher is going to be invoked, that this is the state and according to this state whichever rule is going to be appropriate, that action according to that rule is going to be kind of selected, we can say, and that action is returned. So, a simple reflex agent is going to take the percept as the input and it is going to return an action with the help of kind of interpreting that percept, looking for that state into the condition action rule repository, and it is going to return the action as per that table or that repository. Now, simple reflex agents, if we talk about, they are admirable, they are having the admirable property of being simplistic, being very simple. But because of this, this can be a constraint also. They turn out to be of limited intelligence, in the sense that agent will work only if the correct decision can be made on the basis of current percept only. Now, when I am saying I need to make a correct decision on the basis of current percept only, that means it says that the environment must be fully observable, in the sense that even if there is a little bit of unobservability, that can cause some serious troubles. So, that is basically the disadvantage of simple reflex agents, while the advantage which we were talking about is they are simple, but the disadvantages says they are limited, they are of limited intelligence obviously, and they operate best only in the fully observable environment. Even kind of a little observability can be a cause of great concern, we can say. Moving on to the next type of reflex agent, which is model based reflex agents. So, model based reflex agents, if we see into, they are the most effective way to handle partial observability. That means your agent is going to keep a track of the part of the world which it cannot see now. That means the partial observability, in order to handle the partial observability situation, we need to look into these model based reflect agents. And now, in order to handle this partial observability, the agent should maintain some sort of internal state, and this internal state actually depends on the percept history, not only on the current percepts as we did in the simple reflex agent, and thereby this reflects at least some of the unobserved aspect of the current state. So, there is some kind of unobservability in the current state, but that unobservability can be handled with the help of whatever the percept sequence your agent has already kind of gathered, perceived or acquired, and on the basis of that percept sequence or percept history, the internal state of the agent is going to be updated. So, and updating this internal state information as the time goes by actually requires two kinds of knowledge to be encoded in the agent program. The first one is, it needs some information about how the world evolves independently of the agent. That means, if the agent is not available, how the world is actually reacting, how the world is evolving. And the second kind of knowledge which is needed to be encoded in the agent program in order to handle this is some information about agent's own action or how these actions are going to affect the world. So, basically there is a knowledge or there is a sense about how the world is working. Now, this knowledge can be implemented in simple Boolean circuits, or it could be a complete scientific theory or a big complex package, and this either the simple Boolean circuit or the complex scientific theory package which I am talking about is actually a model of the world, and your agent is going to use such a model, and that type of agent is known as model based agent. So, in order to understand model based agent into more carefully, let us see the figure. So, again two sides of the figure, agent and the environment, sensors and actuators are something which you are already aware of. Now, the condition action rules we have seen in the simple reflex agent also, and on the basis of these condition action rules, it is going to be decided that what action I or the agent should do now, and with the help of sensors it is going to gauge that what the world is like now, but state then how does the world evolve, and what my actions should do. So, the two important parameters that how this world has evolved, that means some knowledge about that evolution of the world, or that means if the agent is absent in the world, how the world is going to react, and if the agent is present and doing some actions, so what the actions of the agent are going to do. These two dimensions that we have seen are actually required to be encoded in the model, and with this model your this model based reflex agent is going to work. Other blocks or other elements of the diagram, if you can see, we have sensors over there, what the world is like now, then condition action rules, what action I should do now, and the actuators are we can say as similar to the previous one, which was the simple reflex based agent. What is the difference between the two is the two dimensions of encoding some of the internal state in order to handle the partial unobservability. These two dimensions, that how the world evolves and what my actions will do in the form of a model, are going to be kind of, we can say, used within the agent. So, this is actually your model based reflex agent. Moving further, if we look into the next one, which is the goal based agents. But before going into goal based agents, some of the points which I need to look upon in the model based agents is these model based reflex agents keep the track of the current status of the world using an internal model. This we talk about, and in this way they are able to choose a particular action. Update state is there, which is responsible for creating the new internal state description, and how this model works, or how this model and states are represented, they actually depends on the type of environment and the particular technology used in the agent design. As I have given the example that this could be a scientific complex theory, or this could be a simple Boolean kind of circuit, I can say. Moving from model based agent to goal based agents. So, goal based agents, when we talk about, that means knowing something about the current state of the environment is actually not enough in order to decide what to do. So, for example, at a road junction, the taxi can turn left, or it can turn right, or it can go straight, and the current decision depends upon where the taxi is trying to get to, or what is the actual destination of the taxi, or we can say what is the actual goal of the taxi. In other words, we can say that goal along with the current state description is something that the agent needs. Agent also needs some kind of goal information that describes situations that are desirable, for example, being at the passenger's destination. The agent program can combine this goal information with the model to choose the action that achieve the goal, that is whether you want to move left, or you want to move right, or you want to go straight. That totally depends on your goal. But sometimes this goal selection is straightforward, as we are talking about. Sometimes this goal selection could be more tricky, we can say. So, for example, when the agent has to consider long sequences of twists and turns in order to find a way to achieve the goal, so that means this goal finding is going to be tricky, or this goal finding could be straightforward when the goal satisfaction is going to be resulted immediately from a single action. Although the goal based agents appear less efficient, but they are more flexible because the knowledge that supports this decision is represented explicitly and can be definitely modified. So, here if we can see in the figure that what is the difference from the previous figure, if you can see, is the block that what it will be if I do action A. So, if I am going to move right, how it is going to affect my goal, or how it is going to be what is going to be the next state if I am going to move left, and everything, the action, what action I should do now is going to be decided on the basis of goal, we can say. So, this is what your goal based agent is. Moving to the fourth type, which is the last type, it is utility based agents. Now, goals alone are not enough to generate high quality behavior in most of the environments. Let me give you an example here. So, for example, goal is to reach over kind of a particular destination, fine. But if you are going to reach there by braking 4 times or jumping the red light 4 times, that is not going to that's not going to suffice. So, a performance measure is going to assign a score to any given sequence of environment states. So, it can easily distinguish between more and less desirable ways of the utility function getting to the taxi's destination. So, getting there on time, or just getting there and getting there with 4 red light jumps, that means the utility in this jumping scenario is kind of, we can say, decreased. So, agent's utility function is essentially an internalization of the performance measure, and if the internal utility function and the external performance measure are in agreement, then an agent is going to choose the actions to maximize the utility, and that is going to be the rational according to the external performance measure also. Any rational agent must behave as if it possesses a utility function whose expected value it tries to maximizes. And if we need to look into, on the basis of this description, if we need to look into the utility based agents, here is what is the difference between this and the goal based agents is, utility says how happy I will be in such a state that how my performance measure is going to be maximized, and on the basis of this it is going to be decided that what actions I should do now. So, basically when we talk about utility, that means your the agent should possess an expected utility function that can make rational decisions with the general purpose algorithm that does not depend on the specific utility function being maximized, and this we have also understood with the help of a figure. So, in this lecture we looked into 4 kinds of agents. One is the simple reflex agent, then next one was the model based agent, then comes goal based agents, and finally utility based agents. Here is the reference from which this lecture has been prepared. The reference is being shown on the screen, which is the book Artificial Intelligence, a Modern Approach, written by Russell and Norberg. That is all from my side in this particular lecture. I will see you in the next. Till then, take care. Goodbye.